Look at this one here. Now, most of this is going to be okay, except for look at the guy on the right-hand side. Look at g of x. G of x is that weird function that you're only going to have to deal with very rarely, okay? It's the one, if you go back to 3, 4, it's the one that had the filled in dot, moved over, had the open dot, then you went up, filled in dot, moved over. It's called the greatest common integer function, or they'll call it a floor function, okay? The reason they call it the floor is we're looking at the greatest common integer at the floor. They also have a ceiling function, which means we're going to be going up. This one, we're not learning the up one, we're learning the down one. When I show you the bottom part, I'm going to show you the domain. And then I'm going to briefly explain the domain to you, how they got it. And then I want you to realize, keep it in mind, but don't let it occupy too much of your brain space. But just realize, if you ever see it again at some other math class, go Google it and it'll all come back, okay? But don't freak out on it too much, going, is this on the midterm? No. So there you go. So look at the first part of it, and it says, hey, find the formula f plus g of x and simplify your answer. Notice they're not saying evaluate, they're saying you're going to compose this function. You're going to put it together, not compose, but you're going to put these functions together. Well, realize that whenever you have f plus g, okay, you're really just going to take this f of x here and add it to g of x and do any simplification if necessary, okay? So notice my f of x is the square root of x plus 2. And then I have plus this x minus 1. There you go. You literally just added the two functions together, right? Okay. Now the domain. Okay, hear me out. The domain of this function right here. Okay, for right now, the domain is always all real numbers. It's just like a parabola, okay? It's all real numbers, so don't worry about it. So the only thing there that has a restriction is what? Yeah, the square root. The square root has a restriction. So you got to come in here and go, okay, well, the domain is going to be, well, I have the square root of x plus 2, which means this guy right here has to be x plus 2, has to be greater than or equal to 0. So you get x is greater than or equal to -2, which means my domain is this. Does everybody understand how I got it that way? Okay. Okay. And the reason I put this in your notes for your homework. Notice the next one. Now we're going to be dividing functions. Okay. Simple enough, really. You're just going to put f of x on top, g of x on the bottom, right? Let's go down here. So we have f of x here. We have g of x here, which means we're just going to have the square root of x plus 2 all over what? This x minus 1 on the bottom. Okay. Just trust me on this one. Okay. I'm going to try to explain it because they are a little bit hard. I'll be honest. I haven't had to deal with one of these functions in a while. And so I had to go back and kind of go, how do these work again? Okay. Let me explain this guy on the bottom first and how it works. Okay. A greatest common integer function literally states this. And how you would write it is this way if you were solving for it, okay? You look for the integer of what you're trying to see. And I have this x minus 1 here, okay? So I got to find out what's the greatest common integer in there. Well, it's not as tricky as what you might think. But how they work is this way, if I just gave you the base, and I'm gonna write over here in red, this is not part of this problem. I'm showing you how these things work, okay? If I give you something just like this, here's just a normal common one, and I said, hey, 0.9. Well, the greatest common integer for that one would be 0. Because the next integer up is going to be what? A 1. We're not going to 1. This is what's called a floor function. You're always going down to the nearest integer. Does that kind of help you see it now? So if I have, okay, let's test it again. What would be the answer for that one? Exactly. Well, how about 1.0? Yeah, 1. How about 1.9?
Still 1.
Still 1. You notice what's happening. It's always dropping back down to what? 1. That kind of help y'all see how it works. Okay, now realize 1. For the domain of this guy, I'm going to write the domain for you so you see how it works. Just see what it looks like. And then I'm going to explain where I got the numbers. Because remember, it's the intersection, okay, of what both of them are. Now, here's the thing. These are really hard to graph in Desmos. They're not impossible to graph. They're just really hard to graph. These are, okay? Square roots are easy. Just whenever you do the square root, if you want to see the domain, make sure it's greater than or equal to 0. Make it equal to something, okay? So the domain of this guy is going to be -2 to 1 union 2. Sorry, and I messed up there. Remember, be very careful with your signs, okay? They do mean things. 2 to infinity. Okay, let me parse this out for you real fast. First off, I do have 1 right here. We already know that there's a domain for that guy, isn't it? Okay, the domain of this one is going to be -2 to infinity. Correct? Well, it's technically in there, but the problem is we've also got that guy happening on the bottom. Now, hear me out. Here's how you figure out the domain of him. Watch what's going to happen here. Are you with me? Here's how I'm going to write it. For the bottom, for this question on your homework, so that way, God forbid, if this ends up being your question on your certify, okay, I don't want you to cheat just to get past it. I want you to kind of see how it works a little bit, okay? I know since I'm dealing with 1, my integers are going to be 1 and 0. Okay, those are going to be the guys I'm worried about. 1 and 0, because I look at the 1 and I'm going to go from there, okay? So look at this carefully. I'm going to come in here and got 0, x minus 1, and 1. With me so far? Add 1, add 1, add 1. Okay? Now, so notice what's going to look, this is going to look like. I got 1 greater than or equal to x less than 2. Okay? Because realize what's going to happen here. Okay? If x is greater than or equal to 1, what's going to happen? It's going to become a what? A 1. But if it doesn't equal 2, it's always going to go back to a what? A 1. What can I not have here? A 1. Okay? I cannot have that. Okay? But I can have a 2, can't I? So notice I have created a domain here. The domain of this guy right here on the bottom right now for this x minus 1 is this 1 to 2. That's the domain of him. Okay, but notice I want to go ahead and equal, okay, the 2. That's okay. So notice for this one right here, specifically speaking, notice how I never equal the 1 here. Okay, but notice how I equal the 2. If I equal the 2, Okay, hear me out. If I equal the 2, what's the greatest common? 2, right? That's the nearest integer. That's the 2. But if I equal the 1, I can't do that, right? Because if I equal the 1, that's my restriction right here. But notice I can't even equal 1.1 because what's going to happen? The greatest common integer says I'm going to do what? Draw it back down to 1, which is why I stopped it. I said, okay, I can't ever equal 1 here, but I can equal 2 because the greatest common. So that's how come there's that weird gap in there. If I can't equal this number, but I can this number, because I can't drop down to whatever that restriction is there. Kind of see it now a little bit better? Play with it a little bit.
Oh, this is like a little, but like if it was like a ceiling function, would it be like
Like a what?
would it like you said it was a floor?
Oh, see, we'd be going up.
Yeah, you would be running
Yeah,
up.
I would go up. Well, so like 1.9, if it was a ceiling function, which y'all don't deal with in this class, a ceiling function, you'd go up. You go up to 2. 1.1 would go up to 2. 1.9 would go up to 2. Is that going to help you out? But since this is a floor function, we go down. Okay? So that's how that will work. Don't get hung up on it. Don't sit here today and go, oh, this is not going to pass or fail you in this class. Okay? Not this question ever. But I do want you to see how it works. Okay? Decomposing functions. Sometimes you got to decompose these guys. Okay? This one's in their book. Okay? But let's look at this one real quick. Okay? Decomposing can be a little hard. Okay? Your homework makes it super easy. Promise. Okay? Functions can be best understood by recognizing them as a composition of 2 or more simpler functions. To decompose, and we've been composing, right? Put them together. We can also decompose them. Okay? To decompose a function into a composition into simpler functions, it is usually best to identify what the function does to its argument from the inside out. That is, identify the first thing that is done to the variable, then the second, and so on. Each action describes a less complex function and can be identified as such. Okay, so we have a very complex function right here, right? I mean, if you really just look at this, and I really want you to start noticing functions within functions. Let's look at this carefully. Before I start showing you how to decompose it, name some functions you see happening in just this f of x. Yes. Okay. I want to be specific. F of x is a function. Okay, a whole function, but it is composed of a whole bunch of little things. Like if I go to the store and buy flour and eggs and yeast and sugar and all these little individual things, right? Those are all functions of themselves. But can I not put them all together and create a brand new function that could be a cake? That's what's happening here. I've made a cake. You're going in and saying, what are the ingredients? Does that kind of help you kind of see a little bit? Name some of the ingredients. I'll help you out. Absolute value. There's a function. Have we not learned about absolute value functions? Can you name another function? Look carefully. Don't look at it as a whole. Even look inside of it if you have to.
The x squared?
X squared, hey, that's a parabola. That's a quadratic function, isn't it? There you go. How about another one? The last one may be a little bit hard. There's a linear function in there. It's harder to see. When I decompose it, you'll see it. Okay? You see what you just did there? You literally, someone just said to you, hey, have a cake. What are these ingredients? And you just told them the ingredients. Okay? Maybe you forgot one. So sometimes, and yes, this is not the only way. Okay? So here we go. Let me write this out. We're going to do A and B. A. Okay, notice. We're decomposing. So my g of x, now I'm not going to use f of x. Can't use f of x. F of x is already defined, isn't it? F of x is that what we're looking at. So I'm going to create a new function, g of x. Okay, we just tend to just use the alphabet because remember, it doesn't matter. So my g of x, I'm going to call this. G of x is just going to be, hey, how about just the absolute value plus 2? Can you see an absolute value function and then we've added 2 to it? Yeah. Is that not what is happening? But notice I've got another function. If I look inside the absolute value function, don't I have another function happening? Well, yeah, I have another function in there. Let's call it h of x. And h of x is x squared minus 3. So realize you've created a function. Okay, you've composed it. Remember, we're working backwards, right? So look at this. This we've already decomposed. That would be the decomposition right there. We've now decomposed those into 2 separate functions. But let me show you why it works. Look what happens. G of h of x looks like this, right? Remember, you figure out what the h of x is first, right? Well, what is h of x? Doesn't it tell me? Isn't it this? So then, therefore, I can take that and write g of x squared minus 3. Well, what is that? Isn't that, remember whenever you don't think of these as numbers, didn't I just solve for my h, right? Solving for my h is this. When we solve for h, then what do? We replace this with what? Yeah, we just kind of keep working our way up. And then this gets put into there. Well, watch what happens when I put that into the next part. So basically, since I have that g of h, doesn't that just become equal to the square root of x squared minus 3 plus 2, which in turn is equal to our f of x function that we just found. Because it matches, right? Work backwards. You're giving the same looks that I gave whenever I first did this in this class. Okay, and that's fine. Because this is a little weird. Okay? If I showed you this, you would be just fine with it. If I said, hey, if I said you have g of h of x, right? And I said, let's evaluate this for when x is equal to 3. Can we all agree that this will turn into g of h of 3 first? Right? You plug in the 3. That's literally what I did right here. I plugged into 3 right there, and therefore, then what happens? When you plug in the 3 here, that whole 3 is going to turn into what? G of 3. We don't know the function. I'm not playing with the functions up here. We're just playing with numbers, right? So that term will turn into g of 3. Well, that's what happened here. This g of 3 became that. Okay? And so therefore, this x here, right here, had to go into that guy there. Kind of help you see it a little bit better? Now, notice you can compose it into 3. Now, this one says compose it into 3. Decompose it into 3. You can do it again. Remember, you're just kind of going down the rabbit hole. You're saying, hey, here's the outside function. Here's the main guy. Now it's happening on the inside. And now it's happening here. So when this one gets figured out, I can go to here. And then go back to here. And then it gets back up to my main function again. Okay? So notice whenever I do this in 3s. Come in here. Notice I said to you there's a linear in here. How about I do this? G of x is equal to x plus 2. Kind of makes sense, right? A little bit. H of x is equal to the square root of x minus 3. And then I also have a j of x, which is equal to x squared. So realize you have a composite function. I have just now decomposed that into 3. Let me show you why it works. Now, this next step is literally me putting it all back together, okay? Remember, we work from bottom up. You're going to go from here to here, and then from here to here, okay? So notice what I have here is G of H of J of X. Yeah, that thing's ugly, isn't it? You don't have to write all this down. This is like proof of concept. My J of X is equal to what? Isn't J of X equal to X squared? This guy right here is equal to what? That guy. So let's rewrite. G of H of X squared. Well, what do you do whenever you're messing with functions? Wherever there's an X, you do what? Replace that with what? I'm looking at the H. Don't I take this X squared and put it right here? Isn't that what you do with a function? Okay, well then do that. And notice that now you have G of this X squared minus 3. Well, what do we do with this? Don't we replace this with that? And we finally get what is equal to X squared minus 3 plus 2, which is equal to what? Our original f of x. Does that help you see it now? All you're doing is doing what you've done. When a function says evaluate this function at this, you're saying, when I evaluate j of x, what is it? There it is. Well, then j of x is gone. You're left with just that. Well, then you got h of that. Well, we do that. Replace it wherever x is in the next function up the ladder. And then replace it again up the next function up the ladder. Okay. You okay? Algebra all of a sudden took a turn, didn't it? I'm like, whoa, okay, we're not in intermediate anymore. Okay. Trying to see if there are any more major problems. Had a few problems on here that you could look at. None of them as bad as that last one. That one right there is pretty straightforward. Be careful with this one. Let me go ahead and I think this is the one. Yeah, let me work this one real quick for you, and then I'm gonna show you one more, and then we'll get into a couple of review questions. Mainly for this one, I don't really, if you're okay with it, I'm gonna leave step 1 up to you. You can look at it in the notes today. Pretty much look at step 2. Realize here that whenever you see this one here, you're gonna have the cube root of x divided by what? Well, remember, that's actually the square root, right? Of x cubed. Okay? Now, hear me out. There's a restriction, isn't there? One of those has a restriction. Which one is it? Well, first off, let's just be honest. There is a restriction, period, because you're dealing with a division, and division you cannot have what? A 0. I know there's going to be a restriction in the denominator because there's a what in the denominator? A variable. Anytime you see a variable, I don't care where it's at. Anytime there's a variable in the denominator, there's going to be a restriction. Somewhere. Okay? But specifically, also, a square root has a restriction, doesn't it? Okay. So if you took this out and say, okay, the square root of x cubed, well, x cubed has to be greater than or equal to 0, which means what? I mean, let's be honest. You take the cube root of both, or you take the cube root of both sides, you just get what? You get 0. X has to be greater than or equal to 0. So what would be my domain? 0 to infinity? Okay, 0 to infinity, that's the answer. Is that interval notation?
It's equal to.
And linear? What's the problem with that? And that's where I got you. Look carefully. Yes, you would be right if that was just a domain. But here's the problem with that. Look at it carefully. What happens if that got 0?
It's undefined.
It's undefined at that point. So while the function says, yes, my domain is greater than or equal to 0, if you equal 0 here, then what's going to happen? It's undefined at that point. So you cannot have it equal to 0. You need to come in here and make sure that you put a parenthesis there. Okay? So watch out for that because you can't equal 0 there. Even though if I showed you, this is a very valid domain right here for this guy here in just a normal sense of the word. But if he is sitting in a denominator, you can't equal 0 anymore with that guy. Because if you do, it's undefined. So kind of watch out for that. That help you see them? That's kind of wanted to show you them because I figured you might be getting red bars and I understand why you would get or why it can't equal it. Okay. One more, kind of a visual representation of how compositions work. Notice I have two functions here. I have a linear function. What is that other function? Very good. It's a cube root. Okay. It's always good to always do some remembering, right? I have a linear and I have a cube root. So this is how you would solve this one. It says, give me the answer of f composed of g when they equal 4. Remember, you work from g first. Well, if I said g of 4, here's my function right here, right? Of g of x here. Well, let's look at it. When g is 4, the 4 is always going to be our what value? X or y? X, exactly. So I come over here to 4, and then look, I go down. Hey, g of 4 is equal to what? -3. Well, then what do I got to do? I take that -3 and place it where? Into the f function. So now I'm looking for f of -3. Come over here to -3, and then I go up 1, 2, 3, and there it is right there. So the whole answer to this guy is going to be what? 4. That's how they work. You figured one out, g of 4. What is g of 4? If I gave you a function, you would solve for it. When you solve, is that not what you're getting? When you say g of 4, you're saying the x is 4. Where am I at on the axis? Where am I at on that line? It gives me a y value. You take that y value, you plug it into the next function. That's how compositions work. You just kind of keep doing the plugging in process over and over and over again. It's functions working together. Now, to be honest, on some of these, let's see if there's any weird one on here. I don't believe there is. No, not in this one. You know what? Let me do one more. I'm just going to show you the composition part of it because you're going to get a blue bar and you're going to be mad at me about it for some reason. Because that's how it works in math classes. You get mad at the math teacher. There it is up there. Notice this one says this. Look at it carefully. It says you're going to compose this function yourself. Okay. Now I give you step 1 and step 2 on this. I'm only going to do step 1 because hopefully you can see how it works. Okay. Write the formula f composed of g. You're basically combining these two functions into one. Remember, when you're doing f composed of g, hear my words, f composed of g. You're taking the g and placing it into where? The f. You're seeing it like this. You're seeing f composed of g of x. Do we not have a definition for g of x?
Yeah.
What is it?
X minus 2 over 2.
Exactly. So since I know x minus 2 over 2 is g of x, you're seeing f x minus 2 over 2. And whenever you have f of something, what do you do with the something? Replace it with what? You take that and put it where?
Yeah.
Everywhere there's an x value in f. And so this one right here, I would replace this as, I'm not putting it inside yet. I'll show you why. There's an x minus 4 inside this function, right? The f function. I'm replacing x with x minus 2 over 2. And then I've got that minus 4 and the whole thing, take the square root of it. Because you had to come from here backwards. Now, it would not work the same. G composed of f would not work that way, would it? I would have to take the f value and place it where? Into the x value for the other one. But let me show you why you're going to probably get a blue bar. That's not simplified. Okay, maybe it'll take it. I'm saying it's not simplified. So go ahead and simplify it real fast. Okay, so notice you don't have a common denominator. So come in here, x minus 2 over 2 minus, well, that's 4 over 1, right? Which means I can take this to do what? Multiply by 2, multiply by 2. Then I get x minus 2 minus 8 all over 2. Hey, 2 minus 8 is what? Negative 6. Sorry, say it again.
Negative 6.
Negative 2 minus 8.
Negative 10.
Thank you. So you've got here what? X minus 10 all over 8. So just make sure to do that. In your notes, I didn't I did, yeah, I over 2, not 8. Why am I like that? And then notice domain. Don't you just do the same thing you always do the square root? Come over here, take out the inside and go x minus 10 over 2 has to be what? Greater than or equal to 0. Solve, multiply that up, that just becomes 0. X minus 10 is greater than or equal to 0. And so you know that your domain is going to be 10 and 50. Okay. Good? Okay. I want to show you that one. So that's along with that greatest common integer or floor function, those are probably the more tricky ones that you're going to have on your homework. Okay. And that, ladies and gentlemen, is for 3. Okay. Any questions on that? One of the more weird ones, I get it. You're going to see it a lot. Okay, that kind of composition of function a little bit. It's going to pop up every once in a while. Don't forget Monday's your midterm. I'm going to look over the midterm questions real fast. Answer any questions if you have any.